Hello, ma'am.
Good evening, sir.
Good
Ma'am,
evening,
yeah.
sir.
Good evening. Give me 2 minutes, ma'am. You make me the host. I'll come back.
Okay, sir.
Good evening, everybody.
Good evening,
Good
sir.
evening, sir.
Yes, yes. So we'll start with a new chapter today, coordination chemistry. It's an inorganic chemistry. It's a branch of inorganic chemistry. We will learn the coordination chemistry chapter. Any clarification with the kinetics you have? So we've learned kinetics also in very detail. We have any clarification so far?
No, sir.
No. Okay. Others also have no doubts. All right. So that's the case. We'll start with a new chapter, coordination chemistry. Now, we all know that acid and a base reacts to form a salt. Acid and base reacts to form a salt. Now, this coordination chemistry chapter, what we're learning, it is also called as coordination compounds. It is also called as coordination compounds, or it is also called as complexes. It's also called as complexes, coordination complexes. Now, I started with the reaction acid and base gives you salt. And we're talking about a coordination compounds or coordination compounds, coordination compounds. I wrote it as complex, coordination compounds. And we're talking about complexes. Now, the understanding is this coordination compounds or complexes are also an inorganic salt. It's also an inorganic salt. Now, what do you mean by coordination compounds? We will learn it in few minutes time, but we will take some of the examples. Now, this inorganic salts is classified into three. It's classified into three. The first one will be called as a simple salt. Now, when I see the first one will be called as a simple salt, sodium chloride we will take as an example. When the sodium chloride is dissolved in water, the sodium chloride will give sodium ions and chloride ions. All right. Have you done inorganic salt analysis in your laboratories, in your colleges, schools? Inorganic salt analysis, acid radical analysis, basic radical analysis. Have you done?
Yes, sir.
Yes. Now, what will be the confirmatory test for chloride? What's the confirmatory test for chloride? You react with AgNO3. So you
Yes,
get white precipitate of what? AgCl. Or in some of the schools, they would have asked you to do chromyl chloride test. Chromyl chloride test. So silver nitrate test or chromyl chloride test is a confirmatory test for chloride. Now, for what's a confirmatory test for sodium ion? Have you done something called as flame tests? Have you
Yes, sir.
heard metals give different colors?
Yes, sir.
Yes. Now, why sodium chloride if you take and if you make a solution of sodium chloride and you subject it to test for chloride and sodium, it acts separately. Because the sodium in water, it will give simple anion and simple cation. So positive ion will be called as cation and the negative ion will be called as anion. So any salt which will dissociate in water to give simple anion and cation, which will answer the tests for inorganic salt analysis, those are called as simple salts. Those are called as what salts? Simple salt. A salt which dissociates in water to give simple cation and anion is called as a simple salt. These simple ions which are formed will react and give their confirmatory tests based on their inorganic salt analysis. Followed with this, first is the simple salt. The second is a double salt. What do you mean by a double salt? The name itself says double. Now, for example, if you take ferrous sulfate, did you use ferrous sulfate anywhere in the laboratory? FeSO4? Have you used ferrous sulfate? Have you used ferrous ammonium sulfate?
Yes, sir.
Ferrous ammonium sulfate. Have you
Yes,
used
sir.
called as Morse salt?
Yes, some more also.
Yes, Morse salt. Yes.
It's a
Now,
titration experiment.
in the titration experiment you would have done, and also you would have learned, sometimes they would have used in the brown ring test also for
Yes, sir.
nitrate radical. That's
Yes,
okay. Now, this ferrous sulfate, when allowed to react with aluminium sulfate, all right. Now, 1 molar ferrous sulfate solution you are taking 1 molar aluminum sulfate. You are mixing it in a container and you are heating it to dryness. When you heat it to dryness, you get FeSO4, Al2SO4 thrice, and dot 6H2O. This is called as ferrous ammonium sulfate. It's called as what? Ferrous ammonium sulfate. It is abbreviated as FAS, ferrous ammonium sulfate. No, sorry, I took a aluminum, right? Sorry, I should have taken, wait, sorry. I should have taken ammonium sulfate. This is ammonium sulfate. So when we take ferrous sulfate and ammonium sulfate, all right, NH3 twice, NH3 twice. So you get NH3 twice. All right, I'll rewrite it otherwise. Wait for a minute. Ferrous sulfate, and you will take ammonium sulfate or aluminum, ferrous aluminum sulfate. Or else, wait, we'll take one more example. I forgot this, man. This moment, wait, I'll see. It's correct only. Yeah, it's here. Aluminum sulfate, potassium aluminum sulfate. I took ferrous, okay. Sorry. So instead of using, this is also example for ferrous double salt. Okay. Anyways, for double salt, you take potassium sulfate and we will take aluminum sulfate. Equal concentrations, 1 molar and here also 1 molar. And this you heat it to dryness. When you heat it to dryness, we will get potassium sulfate, aluminum sulfate, and you will get 6H2. This is called as potash alum. It is called as potash alum. It is an example for double salt. Now, this is a solid. It is a solid. See, double salts, if I dissolve it in water, if this double salt is dissolved in water, this will dissociate to form potassium ion. It will give sulfate ion and also it gives aluminum ion. Now, the question is, what is the confirmatory test for sulfate? Sulfate radical is confirmed by adding barium chloride. When you add barium chloride to sulfate radical, you get a white precipitate. You have done this?
Yes, sir.
Yes. Now, aluminum you have done. Have you heard of something called as gelatinous white precipitate? Third group basic radicals, aluminum radical. So if you add ammonium chloride and ammonium hydroxide, you get a gelatinous white precipitate. Have you heard of it?
Yes, sir.
Yes. So aluminum also will answer. For potassium, do you have you heard it gives you lilac color flame or violet color flame test?
Yes, sir.
Yes. That means a double salt will behave like a simple salt in aqueous medium. Only in its solid state, it maintains its identity. Only in solid state, it maintains its identity as what? A double salt. So a double salt is a combination of two simple salts. Potassium sulfate is a simple salt. Aluminum sulfate is also a simple salt. When these two simple salts are mixed up, equal volumes, equal concentration, and heated up, you get a double salt. This double salt will maintain its identity only in the solid state. In water or in aqueous medium, it will dissociate to give simple ions. Did you understand what is a double salt? No problem.
Yes,
Did you
sir.
follow? Others?
Yes, sir.
Yeah. Now, the third inorganic salt what we have is called as a complex salt or a coordination compound. The third inorganic salt. Now we're getting into the chapter. We're going to define. The third what we have is complexes or coordination compounds or coordination compounds, complexes or coordination compounds. These coordination compounds are also what basically inorganic salt. Now, for an example, if I take potassium cyanide, KCN. Now, potassium cyanide in water, will it dissociate to give K plus and Cl minus? Yes or no? Cn minus? K plus and Cn minus? Yes or no?
Yes, sir.
It is a simple salt. Likewise, if I take ferrous cyanide, FeCl twice, this also is a simple salt. So if you take equal volumes of potassium cyanide and ferrous cyanide, what happens is these will react to form K4 FeCl6. It will form K4 FeCl6. It is a solid. It is a solid. When you dissolve this in water, this will dissociate to form 4K plus you will get FeCN6 4 minus. This is how the dissociation is. This is solid. It's a solid. In water, it will dissociate to form. Now, if I take this compound and if I perform a flame test, will I get lilac color for this? Yes or no?
Yes, sir.
So potassium is free. Therefore, it gives you lilac color. Will it answer the test for iron? Will it answer the test for cyanide? Are they free? Cyanide ion and iron, ferrous ions, are they free?
No, sir.
No. So they will not give you the test for simple radicals. So coordination compounds, they maintain their identity in solid state as well as they maintain their identity in solution state. Now, what is this coordination compounds? We will define what is coordination compounds in few minutes time. So far, you understood that coordination compounds are also an example, is also an inorganic salt. Coordination compound is also an inorganic salt. Correct? Did you follow this?
Yes, sir.
They can ask you examples for a double salt. There are few examples for double salt. We are going to learn that. Now, a salt is formed by the reaction between an acid and a base. Now, an inorganic salt is of three types. A simple salt. A simple salt will dissociate in water to give simple ions. Those ions can be detected by a simple acid radical, basic radical test. Now, when we say a double salt is a combination of two simple salts which maintains their identity only in the solution state, but in aqueous medium, they behave like a simple salt. Now, coordination compounds are inorganic salts. That is what I've defined. I have not completed the definition of the coordination compound. We will learn about it. Now, let's see. All transition elements, when I say transition elements, D block elements are characteristic, has a characteristic property of complex ion formation. So alkali metals will not have the ability to form the complex. Only D block elements, D block metals will have the ability to form the complex or to form the coordination compounds. The compounds containing complex ion is called as coordination compound. The complex containing coordination ions, or the complex ions are called as coordination compound. Just now I wrote K4 FeCN6 and I wrote this will dissociate in water to give you 4K plus I told you FeCN6 4 times. 4 minus. See, this is a complex ion. FeCN6 4 minus. This is a complex ion. So a compound which contains a complex ion is called as coordination compound. It is not the complete definition. We will have to learn the definition a little later. The branch in chemistry which the coordination compounds are studied are called as coordination chemistry. What is coordination chemistry? It's a branch in chemistry which deals with the study of coordination compounds. Now, double salt and coordination compounds. When two solutions of two or more stable compounds are mixed in stoichiometric proportions, a new crystalline compounds called molecular or addition compounds are formed. There are two types. I told you a double salt is also formed by the combination of two simple salts. Coordination compounds or the complexes are also formed by the combination of two simple salts. I told you. Now, double salt. Addition of compounds stable in solid state dissociates in aqueous solution such as to give test for the constituent ions. I told you a double salt will maintain their identity. Maintain their identity only in what state? Only in solid state. And these double salt, they behave like simple salt. They behave like simple salt in aqueous medium. I told you this double salt maintains their identity only in the solution state. Maintain their identity only in the solid state, but in the aqueous medium or this solution state, they behave like a simple salt. You can see carnallite is an example for a double salt. KCl is a simple salt. Magnesium chloride is a simple salt. Combination of these two, they will have their identity only in the solution, solid state. But in aqueous medium, they give simple ions. They behave like a simple salt. Likewise, potash alum. Potassium sulfate is a simple salt. Aluminum sulfate is a simple salt. And when they combine with equal proportions, they give a solid called as potash alum. Potassium sulfate, aluminum sulfate, dot 24 water molecules of hydration. They maintain their identity only in the solid state, but in aqueous medium, they behave like a simple ions. Likewise, ferrous ammonium sulfate. One more example, ferrous ammonium sulfate. This ferrous ammonium sulfate is also an example for a double salt. It is a combination of ferrous salt and ammonium sulfate. Dot 6H2. This also, they give simple ions, ferrous ions, sulfate ions, and also they give you ammonium ions. So a double salt will maintain their identity only in solid state. In aqueous medium, it behaves like a simple salt. They behave like what salt? Simple salt. Did you understand this so far?
Yes, sir.
Yes. Now coming to
Yes,
the
sir.
concept. See, this is an important question. You are expected to identify the simple salt, double salt. They can ask you, or they can ask you directly. Give one or two examples for a double salt in your regular 12th standard exam. Now, coordination or the complex compound. Now, this coordination compound or a complex compound is an addition compound, stable in solid state, and they retain their identity even in solution state. I told you, coordination compounds are complexes. They maintain their identity in the solid state as well as in solution state. Now, the central metal ion form dative bond or coordinate bond with the species surrounding it. And this is called as a ligand. We are going to learn what is a ligand later. Now, what is the coordination compound? Now, if you take an example, K4FeCN6. Now, this K4FeCN6 is a complex compound. This maintains their identity in solid state as well as in solution state. When you dissolve it in water, you see it dissociates to form 4K plus, and you get a complex ion. We get a complex ion, 4 minus. Now, this complex ion, whatever is in the square bracket, is called as a complex ion. Remember, whatever we are going to write henceforth in a square bracket will be called as a complex ion. Outside the square bracket, whatever we have, they are called as counter ion. They are called as what ion? Counter ion.
So counter.
Yeah, whatever is in the square bracket, they are called as complex ion. Complex ion. They are also called as ionization sphere. It is also called as what sphere? Ionization or coordination sphere. It's also called as coordination sphere. Ionization sphere, or it's also called as what? Coordination sphere. Now, this potassium ferrocyanide, when dissolved in water, it dissociates to form 4K plus and FeCN6 4 minus. Now, you should remember this ion is a D block element. Now, the metal, see, potassium is also a metal, iron is also a metal, but iron is in the square bracket. So, iron is present in the complex ion. Since this ion is present in the complex ion, this ion is called as central metal. It can be in atomic state or it can be in ionic state. CMA, we abbreviate it as central metal. The central metal is surrounded by definite number of atoms or molecules or ions. Okay, those are called as ligands. Those are called as ligands. In this example, cyanide is a ligand. We will learn what is a ligand. Now, what is a complex, or how do we define a coordination compound? A coordination compound is an addition compound. It's an inorganic salt which contains a central metal atom or ion surrounded by definite number of, fixed number of atoms, molecules, or ions is called as a complex, is called as a coordination compound. What is the definition of coordination compound? It's an addition compound which contains what? A central metal atom or ion surrounded by definite fixed number of atoms, molecules, or ions is called as what? A coordination compound. Did you understand the definition of coordination compound? Students, we will learn with more examples. Did you follow what I was talking about?
Yes, sir.
Yes,
Yes.
sir.
Yes. Now, see, few examples are given here. Now, one is CuNH3 4 times SO4. CuNH3, you can see there's a square bracket here. This is a complex ion now. Now, when this compound is dissolved in water, you get the cation. Cation is CuNH3 4 times 2 plus, and the anion. This is a counter ion. This is a counter ion, and this is a complex ion. Now, if you take K2PTF6, you get cation potassium, and you get PTF6 2 minus. This is a complex ion. And if you take this, you have CONH3 6 times, CrNH3 6 times. The CONH3 6 times has 2 plus charge, and CrCN3 6 times. This is not 3. This is not 3 here. It is Cn 6 times. It has 3 minus charge. It's these both are complex ions here. Both are complex. Even the anion is complex and cation is complex. Now, what is the definition for a coordination compound? Coordination compound, basically, it's an inorganic salt. It is formed due to the addition reaction, and it contains a central metal atom, or it contains a central metal ion, which is surrounded by definite number of atoms, molecules, or ions, and they are called as ligands. They are called as ligands. Central metal atom or ions, they are called as ligands. All right, did you follow this?
Yes, sir.
Students, are you
Yes, sir.
there? Yeah, good, good. All right. Now, coming to the terms which you're supposed to remember. Now, the terminology of coordination compound. The first one is central metal atom or ion. Already I explained. A complex ion contains a metal atom or ion known as central metal atom or ion. And it is sometimes called as nuclear atom. It is sometimes called as what atom? Nuclear atom. Now, for an example, if I take Cu, NH3, 4 times SO4. Now, in the CuNH3, 4 times SO4, this, which is in the square bracket, is called as a complex. The other one outside the square bracket, what we have, is called as a counter ion. The sulfate is a counter ion. The sulfate is a counter ion. And this is a complex ion. Now, in the complex ion, the metal what we have is called as the central metal atom. If this metal is having no charge, then it is called as atom. If this metal has a charge, then it is called as ion. Did you understand? A complex ion containing a metal atom or ion, it is known as what? Central metal atom or ion. And it's sometimes called as what atom? Nuclear atom. Followed with the central metal atom or ion. This part.
Yes, sir.
Yes, sir.
Yeah. Now, coming to the definition, see, this complex ions, what we were talking about. These complex ions, you can see, it has a positive charge. This complex ion has a negative charge. This complex ion has a positive charge, and this complex ion has a negative charge. So any complexes will be generally charged. We have neutral complexes also. We will learn about neutral complexes later. Now, the complex ion, it is electrically charged radical. When I say it is electrically charged radical, it can be either positive or negative charge, which is formed by the combination of simple cation with one or more neutral molecules or simple anions or this, or in some cases positive groups. These are called as what? See, it's an electrically charged radical which is formed by the combination of simple cation. Cation is nothing but metal. Cation is metal. Cation is a metal with one or more neutral molecules, simple ions, or some cases positive groups, and these are generally called as ligands. These are generally called as ligands. So whatever the atom, molecule, or ion attached to the central metal atom is called as ligands. Now, how do you define a ligand? Now, can anyone tell me from your memory what is a coordinate bond? How a coordinate bond is formed? How a coordinate bond is formed? Anyone? Define what is a coordinate bond.
So, So a coordinate bond is when one compound. So it's when one element is it supplies electrons to another element without any. So it supplies an electron to the other element, sir, forming a bond, sir, which is.
All right. It should be a little more specific. Now, to form a bond, we need 2 electrons. Now, if I take hydrogen molecule, each hydrogen atom has 1 electron. When these electrons are shared, then the bond formed is called as covalent. Now, if I take sodium and chlorine, if I allow it to react with sodium with chlorine, sodium gives 1 electron to chlorine. Therefore, sodium gains a positive charge and chlorine gains a negative charge, and force of attraction will be called as form what? Sodium chloride. It's called as what bond? Ionic bond. Now, if I take ammonia and if I allow it to react with boron trifluoride, both the electrons are given by nitrogen to boron. Therefore, you get a bond. That bond is called as a coordinate bond. So what is coordinate bond? A bond formed when both the electrons are donated by what? one atom
So
to
the
the
same atom, sir.
yeah, one atom to the other. So to form a bond, you require two electrons. When both the electrons are donated by one atom to the other, then the type of bond formed is called as coordinate bond. This coordinate bond is also called as dative bond. This coordinate bond is also called as dative bond. Now, we were talking about this example, CuNH3 4 times SO4. Now, the CuNH3 4 time, A4 is attached to the metal, central metal. Now, in case of this ammonia is also called as a ligand. Why? Because this ammonia is attached to copper. Now, in case of this molecule, each ammonia molecule donates one pair of electron. Therefore, what happens is, since we have four copper molecule, ammonia molecule, so you will have four coordinate bonds. This arrow mark indicates nitrogen of ammonia is donating electrons to copper, and it has a 2+ charge. Do you understand? So ammonia is an example for ligand. Now, what is the definition of a ligand? Ligand can be neutral, it can be negative charge, or it can be positive. Now, a ligand which is neutral, ligand is nothing but an atom or group of atom which is neutral, positive, or negative, which can donate minimum of one pair of electron to the central metal atom or ion is called as a ligand. What is a ligand now? A ligand is a neutral molecule or an ion that attached to, it can be positive ion or a negative ion. That's why they said ion here. It's a neutral molecule or ion that attached to the central metal atom or ion is called as a ligand. Now, in other words, we can define ligand as an atom, molecule, not atom, it's an ion generally. It cannot be an atom. Ligand can never be an atom. It should be an ion or a molecule. So generally, molecules are neutral in charge. Ions only are positive or negative. Now, what is a ligand now? Ligand, in simple words, we can define ligands as molecules. Molecules are neutral, or ions. Ions can be positive or negative, which can donate minimum of one pair of electrons to the central metal atom or central metal ion is called as a ligand. Did you understand what's the definition for a ligand now? Ligand is a chemical substance. It's an atom, it's an ion or a molecule, all right, which can donate minimum of one pair of electrons to what? The central metal atom or ion is called as what? The ligand. Depending on the number of pairs of electrons donated to the central metal atom, ligands are classified as monodentate, one donor atom, bidentate, two donor atom, tridentate, three donor atom, four dentate, tetradentate, four donor atom, tetradentate, pentadentate, hexadentate, it goes on. Now, what's the definition of a ligand? Ligand or an ion which donates minimum of one pair of electron to the central metal atom is, depending on the number of pairs of electrons donated, ligands are classified as monodentate, bidentate, or tridentate or polydentate ligands. Now, just see here, monodentate ligands. Now, in case of monodentate ligands, monodentate anionic ligands. These anionic ligands, otherwise called as what? Negative ligands. For any negative ligands, the name of the ligand has to end with O. So negative ligand, the name has to end with O. Now just observe this. X minus, it is called as halo. When I say halogen is represented as what? X. Now if it is chloride ion, it is called as chlorido. If it is bromide ion, it will be called as small b, bromido. So the anionic ligands, the name has to end with O. If it is F minus, it is called as fluorido. And if it is I minus, it's called as iodido. All right. So that is helps. So OH minus, you can see the name is called as hydroxo. Cyanidone, CN minus, it is also called as cyanido. Cyano, or it's also called as cyanido. O2 minus, these all are ligands. These all are monodentate ligands. They can donate only one pair of electrons. What do you mean by monodentate ligands? Ligands which donates one pair of electron to the central metal atom or ion is called as a monodentate ligand. So monodentate, mono stands for one. Ligand which donates one pair of electron will be called as monodentate ligands. So O2 minus is called as oxo. NH2 minus is called as amido. S2 minus sulfido. CNS minus it's called as thiocyanato. O2 2 minus is called as peroxo. O2 minus is called as oxo. O2 2 minus is called as peroxo. CH3CO minus is called as acetato. NO3 minus is called as nitrato. S2O3 2 minus it's called as thiosulfato. NO2 minus it's called as nitrito. CO3 2 minus is called carbonato, and sulfate SO4 2 minus is called as sulfato. Now all these are examples for negatively charged monodentate ligands. What do you mean by negatively charged monodentate ligands? Ligands which can donate only one pair of electron to the central metal atom is called as a monodentate ligand. Followed?
Yes, sir.
Yes,
No,
sir.
I don't know why this pen is not writing. Something is happening. All right, what happened? So far, so good. This pen is not writing. 1 minute. One minute, man. Something happened. So far, so good. Yeah. Now, coming to a neutral ligand. This neutral ligand will not have any charge, but still it's an example for monodentate neutral ligand. So these neutral ligands, they have a special name. Remember, they have a special name. All right. And there's a mistake here. It's not aminito, it's amine. AMMINE. So carbon monoxide is a monodentate ligand. It's called as carbonyl. Phosphine, PH3, it's a monodentate neutral ligand. Phosphine, it has the same name, phosphine. NO, it is not called as nitric oxide. It's called as nitrosyl group. So neutral ligands have a special name. So NO is called as nitrosyl. And ammonia is called as amine, AMMINE. It's not the organic chemistry amine, right? So ammonia here is a ligand. It has to be named as AMMINE. Water is also a monodentate ligand. It's named as aqua. Pyridine is also a monodentate ligand. It has the same name, pyridine, and it's represented as what? PY. It's represented as PY. So now coming to the next, cationic ligands. See, positive ligands are very few in number. Positive ligands are very few in number. One is NO2 plus. It's called as nitronium ion. The second one is NO plus. It's called as nitrosonium ion. And we have hydrazinium ion. See, hydrazine is NH2, NH2. This is hydrazine. Now, nitrogen has a lone pair of electron here. This hydrazine, when allowed to react with an acid, it donates a proton, electron to the protons, and we get NH2 bond NH3 plus. So this nitrogen has only one pair of electron donor. Therefore, it's called as what? Hydrazine. Positive ions, the name has to end with. The name has to end with IUM. IUM. So negative ligands, the name has to end with what? Neutral ligand has special names. Positive ligands, the name will end with what? IUM. Did you follow?
Yes, sir.
Others?
Yes,
All
sir.
right. Yeah. Now coming to polydentate ligand. Poly stands for many. Now, when I say poly stands for many, we will learn two examples now. Can anyone tell me, now we learn bidentate ligand. What is the name of this molecule? What's the name of this molecule? What's the name of this molecule? Organic molecule, CH double bond, CH2 double bond, CH2.
Sir, that's
Sir,
ethene.
alkene.
Alkene, what's the
Sir,
name?
ethene, sir.
Ethene,
Ethene is
sir.
also called as
Ethylene.
ethylene. Now, this ethene, when you allow it to react with excess of ammonia, what happens is the pi bond breaks. Because when you have a double bond, pi bond is a weaker bond, pi bond breaks. Now, from ammonia, one NH2 group attacks this carbon, the other NH2 group attacks this carbon. This is for understanding, I'm telling you. So what you get is, you get NH2, CH2, single bond NH, CH2 and NH2, you will get. So CH2 here, CH2 here. One NH2 to this carbon, the other NH2 to this carbon. Pi bond breaks. Now this has two nitrogen atoms. So they have two donors of donor electron, two pairs of electron donors. Therefore, this is an example for a bidentate ligand. This is called as ethylene diamine. It is called as ethylene diamine. Now, in modern days, they have changed the name for this as ethane. IUPAC name is ethane. 1, 2, long chain is ethane. At first carbon, we have NH2, and second carbon also we have NH2. So ethane, it's called as 1, 2 diamine, AMMINE. Not A double, here it's A single M only. NH3 is A double M. Here it is only one M, A single M ion. This is called as ethane 1, 2 diamine. It is represented by letter En. So En is an example for a bidentate ligand. See here, it's a bidentate ligand. Two donor atoms. Likewise, oxalato, it's a negatively charged bidentate ligand. It's a neutral. Ethylene diamine is a neutrally charged bidentate ligand. Oxalato is a negatively charged bidentate ligand. It has two donor electrons. Two oxygen atoms can donate two pairs of electrons. Likewise, we have dimethyl glyoxymato. It's a negatively charged ligand. It also has two donor atoms, two pairs of electron donors. And likewise, you can see here glycinato, it should be glycinato. Here we have this oxygen donates a pair of electron, and this nitrogen also donates a pair of electron. Since all these can donate two pairs of electron, these all are example for bidentate ligands. Now, what is the definition for a bidentate ligand now? Ligands which donates how many pairs of electron? Two pairs of electrons to the central metal atom or ion is called as a bidentate ligand. Did you understand what is a bidentate ligand?
Yes, sir.
Yes, sir.
Yeah. Coming to a tridentate ligand, electron donors, and tetradentate ligand, 4 pair, 6 ligands, 6 pairs of electron donors. All that we will learn now. Just like that, we'll learn this in few minutes time. What is this? What is this? What is this? Ethylene.
So ethene, sir.
Ethene or ethylene? Yes, both are same. Now, what is this? This also is ethylene. It also is ethylene. Since I have two ethylene, I can call it as diethylene. I can call it as diethylene. When this ethylene is reacted with excess of ammonia, what happens is the pi bonds break. The pi bonds break. Now, once the pi bond breaks, NH2 group bonds here. Here also one NH2 group gets bonded. And between these two carbon, since the valency of nitrogen is 3, only one NH gets bonded. So we have one pair of electron donor, two pairs of electron donor, three pairs of electron donor. It's diethylene. How many amine? Triamine. So ethylene, diethylene, triamine. It is abbreviated as DIEN. So diethylene triamine. So it's an example for a tridentate ligand. Did you understand the structural representation? See, they have mentioned it here. CH2 twice. Here also you can see CH2 twice. Here is CH2 twice. Here also you can see CH2 twice. Did you follow this? Tridentate ligand.
Yes, sir.
Likewise, we can have tetradentate ligand. Tetradentate ligand, ligands which can donate 4 pairs of electron will be called as a tetradentate ligand. Now we'll come to a hexadentate ligand here. Now, what's the name of this molecule? Just now we learned what is the name of this molecule. Can anyone tell me? We learned it. I didn't give you the structure like this. Sorry, wait for a minute. I didn't give you the structure like this, but you should be in a position to identify and tell me. It is N, and here you have H, and here you have H. Can you tell me what's the name of this molecule?
So
Is this molecule-
diethylene diamine.
No ethylene. Here only one ethylene, no? It's only one ethylene, no? It donates 2 pairs of electron. It is ethylene diamine. See here? Ethylene diamine, CH2, NH2, NH2. Or it's called as ethane 1,2 diamine. It's a neutral bidentate ligand. It's a neutral bidentate ligand. Now, these hydrogen atoms, 1, 2, 3, and 4. These hydrogen atoms are replaced by acetate ion, CH2, COO minus, CH2, COO minus, CH2, COO minus. Here it is CH2, COO minus. Now see here, these oxygen also can donate a pair of electrons. Totally, this molecule donates 6 pair of electrons. 1, 2, 3, 4, 5, and 6. It donates how many pair of electrons? 6 pairs of electrons. Therefore, this is an example for hexadentate ligand. What do you mean by hexadentate ligand? Ligands which donate 6 pairs of electrons is called as an hexadentate ligand. This is an important example. This is called as ED, abbreviated as EDTA, 4 times, 4 minus. It's called as ethylene diamine tetraacetic acetato. It's called as what? Ethylene diamine. Ethylene diamine tetraacetato. Tetraacetato. That means it has 6 pairs of electron donors. Since it has 6 pairs of electron donor, this EDTA4 minus will be an example for hexadentate ligand. It will be an example for what? Hexadentate ligand. Did you understand this so far?
Yes, sir.
All right. Now we'll learn 2 more points and then we will stop possibly. The classification of ligands we are going to finish, and then from next class onwards we're going to learn in detail. But just observe this. Now again there's a problem. See, CH2, single bond CH2, and this is NH2, and this is NH2. This is nothing but ethylene diamine or ethane 1,2 diamine. This is the same molecule I've written. Instead of writing it in a straight line, I've just made a curve like this. This nitrogen can donate a pair of electron, and this nitrogen also can donate a pair of electron. Now assume this is a metal. This nitrogen donates a pair of electron, coordinate bond. This nitrogen also donates a pair of electron to the metal, forms a coordinate bond. Now, can I say this compound which is formed is a cyclic compound?
Yes, sir.
It forms a cyclic compound, or it forms a closed ring. Now, a bidentate ligand or a polydentate ligand which can get bonded to the central metal atom or ion to form a ring is called as a chelating ligand. Chelating ligand. What chelates are rings. Chelates are rings. So a polydentate ligand. When I say polydentate ligand, it can be a bidentate ligand. Bidentate ligand, tridentate ligand, or any other polydentate ligand When it gets bound to the central metal atom, they should form a ring. A polydentate ligand bind to the central metal atom, they form a ring, and that ring is called as a chelate. And the ligand which forms a ring is referred as what? A chelating ligand. What is a chelating ligand? A ligand which can form a ring with the central metal atom or ion is called as a chelating ligand. So there are so many examples for polydentate ligands. We discussed bidentate, tridentate, hexadentate, all that we learned. So any ligand, any polydentate ligand, which can get bound to the central metal atom or ion to form a ring is called as a chelating ligand. Understood this clearly?
Yes, sir.
All right. The next what we have is ambidentate ligand. Now, see here, I can write NO2. I can write ONO. NO2, my nitro, and ONO. See, the molecular formula in both the cases are same. Now, if this is a metal, for this metal, nitrogen is a donor atom. And if I have a metal here, for this, oxygen is a donor atom. Oxygen donates a pair of electrons. Both you can see the molecular formula remains same. Here the donor atom is nitrogen, here the donor atom is oxygen. Those kinds of ligands are called as ambidentate ligands. What are ambidentate ligands? A ligand which possesses two donor atoms in forming a complex, it utilizes only one, is called as ambidentate ligand. So a ligand which has more than one type of donor atom is called as an ambidentate ligand. So nitro is an example. See, here the donor atom is nitrogen, here the donor atom is oxygen. When nitrogen is a donor atom, it's called as nitro. When oxygen is a donor atom, it's called as nitrito. The molecular formula remains same. Here you can see cyanide. Carbon is a donor atom, cyanido. Here nitrogen is a donor atom, isocyanido. Here sulfur is a donor atom, thiocyaneto. This is wrong. SCN minus, it's called as thiocyaneto. Cyaneto, because it's a negative ion. This here donor atom is nitrogen. This is called as isothiocyaneto. All right. So these ligands are called as ambidentate ligands. A ligands which can have more than one type of donor atom is called as an ambidentate ligand. Followed. This pi acid ligand we will learn. In the last part of the topic, we have the special topic to be learned based on pi acid ligand. We'll learn about it later. Now, coordination sphere, you know what is coordination sphere? We have been talking from the beginning. So whatever is in the bracket is called as coordination sphere. Generally, complex ion are represented by a box. Ligand with central metal ion, which is kept in the square bracket, retains its identity in the same form, is called as coordination sphere. Or it's also called as non-ionizable. Coordination sphere means ligands with central metal ion, which is kept in the square bracket. Now, coordination number, we will discuss from coordination number, possibly from the next class. Or, okay, we will learn these 2 points now itself. What is coordination number? Number of monodentate ligands attached to the central metal atom or ion is called as coordination number. All right. Now, for an example, if you take this molecule K4, FeCN6, the coordination number of ion here is 6 because we have 6 monodentate ligands. If I take CuNH3, 4 times SO4, now we have 4 ligands attached to copper. Therefore, the coordination number of copper is 4. So, number of monodentate ligands attached to the central metal atom is called as coordination number. Now, what is the coordination number of this? Anybody? If you have understood so far what we were talking, tell me what will be the coordination number of this? What will be the coordination number of this?
So,
Now, yeah, tell me.
So 4.
so 4, sir.
No, no.
Sir,
EDTA is a hexadentate
Sir,
ligand.
2, sir. Sir, 2, sir.
Hexadentate ligand. Hexa means how much?
6, sir.
Sir,
6.
sir.
So, this hexadentate ligand will behave like 6 monodentate ligand, yes or no?
Yes, sir.
Hexadentate ligand can behave like what? 6 monodentate ligand. Yes or no?
Yes, sir.
Therefore, the coordination number of this in cobalt is what? 6.
6, sir.
Now, if I take a molecule like this, please remember coordination number is number of monodentate ligands bonded to central metal atom. If I take cobalt and if I write En thrice 3 plus, what is the coordination number of cobalt? What does En stands for? En stands
Ethylene diamine,
for what?
ethylene diamine.
Ethylene diamine is a monodentate or bidentate ligand.
Bidentate, sir.
Bidentates. So each ligand donates 2 pairs of electron. How many we have?
Yes, sir. 3,
Three.
sir.
Therefore, coordination number will be how much?
6, sir.
3 into 2. Each ligand donates how many pair of electron? 2. Ethylene diamine. Like this, we have this donates how many pairs of electron? 2 pairs of electron. One ethylene diamine gives like 2 monodentate ligands. Since we have 3 ethylene diamine, it will be like how many monodentate ligands? How many ligands? 6. Followed or not?
Yes, sir.
Yes. Others? Followed or not?
Yes, sir.
Yeah. Now we will continue with the next part of the topic, the next class. We'll learn with ionization sphere and other things in the next class. All right. Bye. Madam?
Yes, sir. Thank you, sir.
Bye.